Okay, now I'm going to help you through problem number 4, and this is on page 93. So you start by kind of looking at the problem, seeing here we've got this short-tailed mutant, okay? It seems like normally there's these long-tailed mice, and when that happens you end up getting 4 that are short-tailed and 3 that are long-tailed. So to me that seems like initially we're talking about half and half. So if we say our P generation is short crossed with a long, and our F1 generation is going to end up being 4 short and 3 long. Now it starts getting interesting when you look at the F2 generation, because what they did was they took 2 of these short mice and they ended up getting 6 short and 3 long. Now those are odd ratios. If we go ahead and take those ratios closely, so if you think about this number 6 short and 3 long, and you add them together for a total of 9 mice, then you realize that that's the same thing as 6 out of 9, or 2/3 short, and 3 out of 9, or 1/3 long. That ratio is just like the agouti ratio on page 73. So if you look at that page, it's going to help you solve a problem like this. Now if you remember, on the agouti mice, we saw that same 2/3 to 1/3 ratio, which is weird when we maybe would expect to see a 3/4 to 1/4 ratio. And that can be a clue. That'll help us see that if this is behaving similarly, then maybe having 2 copies of that short allele are lethal. The same way that 2 copies of the yellow allele were lethal with the mice. So what you do is you sort of think, let's try this like a hypothesis. I'll set it up to see if it works. So that's going to mean, let's try it this way with a big L for big L for long. And then you've got a big L and then a big L with a little s for short. Then we're going to take a look and see if that L, 2 copies of that LS would end up making it lethal. And the way you check is you cross with these assumptions and check to see if the ratios match. So let's go ahead and make our mice a little smaller for right now. Move this over here. And let's see if this works for us. So we've got, assuming the parents were this long-tailed mice crossed with a short-tailed mice which has 1 copy of the allele. That's our P generation. Their kids, of course, F1, should be about half and half. Some will get the regular long-tail allele from the one parent, from the short-tailed parent, and some will get, the other half would get the short-tail alleles. So we would get half with long-tails and half with short-tails. So far, that matches our problem, which said they ended up with 4 short-tailed and 3 long-tailed mice. That seems okay. Then you look at the F2 generation, and you say, okay, I'm going to take 2 of these short-tailed mice right here, and I'm going to cross them. And what would you expect from those? Well, they're both heterozygotes, so you would expect to see these, you would expect to see their kids be 1/4 LL. You'd expect to see 2/4 LLS and 1/4 LS. Whoops. But what if these actually died? then would your results look different? Would you instead have, this wouldn't be a 1 out of 4, this would be a 1 out of 3. And this wouldn't be a 2 out of 4, this would be a 2 out of 3. Then would that match our final answer, which had about 2/3 short-tailed and 1/3 long-tailed? Yes, it would. So that's our final answer.